Okay, now we're going to finish up our discussion of the law of sines with a couple of word problems or applications. A 10-meter utility pole, there it is, casts a 17-meter shadow directly down a slope when the angle of elevation of the sun is 42 degrees. Find theta, the angle of elevation of the ground. If you want to try figuring this out for yourself, see if you can do it without my help, pause the video and see if you can work it out. If you want some hints, I'm going to give you some hints, and you can pause after any of the hints and then see if you can take it from there. And then I'll give you the answer. So here are my hints. There are three triangles here. There's the one I've outlined in red, there's the one I've outlined in green, and then there's the big triangle that's made up of sort of both of them stacked on top of each other. That goes from A to B to D. So there's ABC, there's BCD, and there's ABD. Next hint, we're going to be using the law of sines because this is, after all, in the sections about the law of sines. And we're trying to find an angle. The law of sines works when we know either two sides and an angle or two angles and a side. Here, we know two sides of the red triangle. This is 10 meters and this is 17 meters. So we are going to be using the law of sines on that triangle using those two sides and then two of the angles. Next hint, one of the angles that we will use is angle A. It's one of the angles of the red triangle, but it's also one of the angles of the big right triangle ABD. We know that that's a right triangle, and we know that one of the angles of that triangle is 42 degrees. That's what this angle over here is. So from that, we can work out what angle A has to be. That's my last hint. That, together with the law of sines, should pretty much give it away. Angle A is 180 minus 90 minus 42 is 48 degrees. Then, on the red triangle, side A is 17 meters over the sine of angle A, and then side B is 10 meters over angle B of the red triangle would be 42 minus theta. So 17 over the sine of 48 degrees equals 10 over the sine of 42 degrees minus theta. From that, we get that 42 minus theta is 25.9 degrees. And from that, we can work out that theta itself is 16.1 degrees. So that is our final answer. This angle theta here, which is one of the angles of the green triangle, is 16.1 degrees. Okay, second problem. A bridge is to be built across a small lake from a gazebo here to a dock here. The bearing from the gazebo to the dock is south 41 degrees west. So if you faced south and then turned west through an angle of 41 degrees. From a tree 100 meters from the gazebo, here's the tree and it's 100 meters from the gazebo, the bearings to the gazebo and the dock are south 74 degrees east and south 28 degrees east, respectively. So if you stand at the tree, face south, and turn through an angle of 74 degrees, you're facing the gazebo. If you face south and turn through an angle of 28 degrees, you are facing the dock. Find the distance from the gazebo to the dock. That's where the bridge is going to go, so we need to know how long that is. Again, if you want to figure it out without any help, pause the video and try to work it out. If you want some hints, I'm going to give you some hints. You can pause after any one of the hints and see if you can take it from there, and I will eventually give you the final answer. So this triangle here that I've marked out in purple is the one that we're going to be doing the law of sines on. We know one of the sides. We're trying to find another one of the sides. We know the side from T to G. We're trying to find the side from G to D. And angle T here at the tree is 74 degrees minus 28 degrees. Angle D, the angle of the triangle that's at the dock. Now to see that, if I draw a vertical line through that point, that vertical line is going to be parallel to these other vertical lines that are going straight south from the tree and from the gazebo. So if this angle here is 28 degrees, this angle here would also be 28 degrees because these are alternate interior angles. And then if this angle here is 41 degrees, this angle here is 41 degrees. So altogether, the angle at D, this particular angle of the triangle, is 28 plus 41 degrees. Now we want to find the side opposite the tree, opposite angle T, that connects the gazebo and the dock. So you could call that side little t. So we know angle T, we know side little d across from angle D, and we figured out that angle D is 28 plus 41 degrees. So little t over the sine of capital T was 46 degrees, equals little d, which was 100, over the sine of capital D, which was 28 plus 41, or 69 degrees. So little t over the sine of big T equals little d over the sine of big D. T over the sine of 46 degrees equals 100 over the sine of 69 degrees. And from that you can solve and get that T is pretty close to 77 meters.